Ethernet, or when packet over SONET arose and passed away, and all the rest of this, because we had good, clean interfaces between the layers, and because we had well-defined rules for what the layers did. And so this allowed you to actually have forward evolution without having to toss the whole stack. And we kind of like to look at doing something similar as we start looking at virtualization. And it's sort of like one naive thing that we can sort of think of when we say, okay, you want to virtualize the network is you might just say, okay, well, maybe what we ought to do is just stick a V in front of everything. Because that's how you virtualize, right? You put V in front of everything. And that kind of works, but eventually you sort of step back and you ask yourself, what is it we really want to virtualize? What layers do we really want in the stack? And there are some ideas bouncing around about this. I'll kind of share like some of the thoughts I've had. I know we have some folks who have like some interesting other directions we can bring into this, so don't take this as like a handing out of gospel kind of thing. It's more of a like conversation starter. But you can almost imagine saying, what if we had layers that look something like this, where we have a policy layer and an SSC layer, and then an overlay layer. And I'll explain a little bit why this is what's stuck in my head as a starting point. And part of the reason this is what's stuck in my head is we've got an example of app coexistence where you have two independent applications that run in the same OpenFlow pipeline with group-based policy and with service function chaining, where policy can hand off to service function chaining. Now, it's not dependent per se. Service function chaining still does interesting and useful stuff in the complete absence of group-based policy, and that's right and proper. And group-based policy can still do useful and interesting stuff that is not about service function chaining in the absence of SSC. But you have this ability to put them together in a stack where when you match a policy, it can indicate, hey, I want to be handed off to a service function chain. And that service function chain then can carry the traffic through that service function chain and come back to the appropriate place. And one of the things I think we learned, and you can tell me if I'm crazy, Brady, is that when you have multiple layers trying to both manage your overlays that you're dealing with, the tunnels that you carry traffic over, that gets to be really hard. And so that sort of drove home this general desire to look at seeing whether we could have overlay be its own layer, such that if I am a service function chain or I'm a group-based policy layer, I can hand off down to the overlay layer, which is simply doing a very basic, look up, find the overlay topology, and pass stuff onto it kind of approach to things. So is all of this sort of making sense to folks so far, or am I going too fast? Please speak up. You're not the only one in the room if you don't feel like it's making sense. Okay, cool. And so I have some ideas, please don't take them as definitive, about how we can kind of start approaching some of this. And I know there's some other ideas in the audience as well, and I'd like to actually get those drawn out. Because when you look at translating this down towards flow tables, like one of the ways you can think about it is in terms of having a set of tables. Let me get a different color. So you can think of it as having a set of tables in the flow tables for particular layers. So imagine that I have a set of tables for policy. I have a set of tables for SSC. I have a set of tables for overlay. I'm glad that it looks like that way from the outside, because up here it's like, Jesus Christ, I'm screwing this up. And so the idea would be that you would have very clear delineation where all that policy would have to know about SFC is what's the minimum shell of information you need, like the name of the service function chain. What's the first table in the SSC pipeline that I'm going to go to table for? And that would be it. So that if, in fact, you want to sub in something that does SSC differently, you simply have to say, OK, there's going to be a named service chain that comes to me, and I need to have grabbed some set of tables so that that information can be provided to policy. so that we can basically get the handoff behavior there. And then likewise, going from service function chaining to overlay. And there's some interesting question as to whether or not you wind up skipping a layer. So if you've got group-based policy that doesn't have SFC, or whether effectively you have sort of the null service chain, which goes nowhere. It just makes its way to overlay. And likewise, when you talk about overlays, you could also have sort of the null overlay, which is dump the packet out of the system, just have it fall off the end. We're not going to put it on any tunnel from here. And that's sort of the idea. It's not a hugely complex idea. Of course, the devil's in the details. And so I'd kind of like to throw open the room to either A, questions if I've expressed myself unclearly, B, other ideas about either how to handle this app coexistence thing in a sort of a stack-like way, or other layers that we may need in here. So for example, I think you're the one, Flavio, who keeps bringing up correctly. There's one really distinctly unsexy layer that I usually leave out of this picture, which is the ARP neighbor discovery layer, where you have something that just programs a table that handles ARP and neighbor discovery pieces for things. And I'd really like to see if we could sort of work together live to figure out something coherent that can be a framework we can move forward with.
With that last thing, you say it's a shared thing, the ARP neighbor discovery, or is that
I mean, I would not want to have to implement ARP and neighbor discovery again if it were available to me. It's not how I prefer to spend a Saturday afternoon. Yes?
Yeah, so what you're suggesting is that you reserve a set of tables for a specific functionality,
Mm-hmm.
and then you have multiple functionalities, you probably change them as per the reserved table numbers for each of them, right?
Maybe reserve tables? There's an interesting question you actually got at, and I really don't know the right answer for it. That's part of the discussion of, do you have reserve tables, or do you simply have just a very basic service where I say, hey, I'm layer named policy, I need 5 tables, can I have 5 tables? And you get 5 tables, and the next guy comes through. Because it's possible that somebody could write a policy pipeline that's 5 tables, and somebody else could write one that's 15.
Yeah, but then they are all going to be just policy. If you say reserve 15, you get 15 policy tables.
Well, you get 15 tables to build your policy pipeline.
Yeah, so I'm thinking about from a functionality point of view, right?
Uh-huh.
If you're reserving a table for one specific function,
Mm-hmm. Or to be handled by one pipeline. Yes.
so you're automatically also limiting the number of functions that you can run on that.
True. I mean, you got, what, 256 tables total? So don't be greedy. I'm a little bit sanguine about this because I'm trying to remember, most of the folks I've seen, and Flavio and Thomas and Brady, you'd be good to keep me honest. Most of the pipelines I think I've seen are usually less than order of 5 or 6 tables. So it's not like somebody's going to come in and grab 250 tables and crowd everybody out.
Well, and then there's a question of how many will you need coexistence for? Is the other part of it too.
Yeah, how many layers do you have? How many different independent pipelines? Yeah.
You could create tons of apps that could have, their own needs, but you probably won't be running them all together. There's some that you will want to run, but
Well, and go ahead. Somebody says something.
This actually seems to assume that we are only going to deal with the virtual switch, where you have the possibility to have a table. If you have all the tables are of similar, either similar tenure or
arbitrary control.
arbitrary kind of tables. That seems to be the assumption here.
So I will readily admit to a particular kind of bias, which is basically that everyone seems to write everything to OVS. And so I'm aware of the fact that there are all kinds of weird constraints that you get when you write to hardware switches, which thankfully I believe are getting less weird, but over time. But it seems like, and I'm totally willing to be told differently, but it seems like if you want to write an application that's going to talk to a hardware switch, you often have to start by saying, this is the hardware switch, because there's just a lot of variation. And there's work being done to make this easier with things like TPTP and as OpenFlow matures, but I don't get the sense that it's quite there yet. I mean, you may know better than I do. You follow a lot of the ONF work more closely. And so I'm totally willing to be told, no, you're totally out of date.
Well, but even more importantly, what could that look like on a hardware switch?
I mean, it's okay. We can just say that this particular approach we are
We should at least pretend to use the mic so that people can get it on the video.
Thanks.
Yeah.
I mean, you could, that might be something we do build in at some point where you have the ability to have an understanding of what each device is going to support from a pipeline point of view to, if we have a generic kind of thing that's requesting tables, and what tables can you request even from a physical device or something. But at a starting point, maybe this is, we target OVS and then we start looking at what kind of infrastructure we would need to build to support that kind of a request.
So have you considered representing this as a TTP?
No, but that doesn't mean it's not a good idea. So when I say no, I haven't considered it, that's really truly a no, I haven't considered it. It's not any judgment at all about it as an idea. Uh-huh.
So one point I would like to explore here is we are talking about how many services or functionalities is a particular tenant going to require, right? So probably there are sufficient tables if you just consider one tenant. But in a multi-tenant environment, I might have 50 tenants, and each of them may have a different set of functionalities that they may want.
It depends on how you do the tenants. So I had been thinking in terms of, it doesn't have to be this way. This was just like the bias that led to this particular picture. Had been thinking of sort of looking at the folks who are building out pipelines now, like the OVS DB Network project, group-based policy, SSC. They've all been sort of building out, like, just to pick the number 5, so they're building out like a pipeline of 5 tables that could service multiple tenants, right? And then the question about what kinds of services they get in terms of like what policies are applied to that tenant, or what VNets, virtual networks they have, or what service function chains, et cetera, that really comes down to sort of like how they end up traversing that pipeline in terms of them matching, their traffic matching stuff. So
just as a recommendation, I mean, with 255 tables, from a tenant, even if you had one table per tenant, that's, that would, I definitely think it would be a better approach to try and put it as flows based on the table. In other words, have multiple tenants within, you have your flow mods support the tenancy versus a table, because otherwise you're just going to run out,
yeah, I mean, I'm absolutely not saying that it doesn't happen, that that's a good idea to have tenants dedicated to tables. I haven't seen as much of it. See, you've been hijacked.
The main thing for common pipeline, right? You could do that even with like individual bridges right now.
With what?
Individual bridges, bridges connected, like BRIN connected to something else. Just things like that.
There are tricky problems.
Right, tricky problem. But one big advantage this one has is that you could pass meta information
Exactly.
between them, right? So
Yes.
that has to be upfront defined. How would it be that because a particular entity, for example, like policy or something is concerned, the 5 tables that they define, of course they know what the meta information, but between the entities, how would you pass the meta information, and what does that mean?
Well,
those kind of things.
that's part of what we're working on, and maybe it's a good point for like basically Brady and maybe Keith and Thomas to talk. Keith. So it might be, we just had a question about how you pass the metadata around between distinct pipelines in the layers. So it might be a good idea for you and maybe Brady to talk a little bit about how you actually are making that work.
Can my question, and then I'll hand it over to him,
Sure.
is this is still pretty high level.
Oh God, yeah.
Yeah, and so it would help me.
Like I'm waving my hand so fast I'm almost floating.
If you could maybe just go maybe a level down and just kind of give us an idea about what you think is in the policy. I kind of think I understand what's in SFC or enough for the model, but what's in policy and what's in overlay? What kind of things happen?
if you wouldn't feel imposed on Keith, do you want to talk to that, or do you want me to try and just wave my arms at it?
Just a little more description about what is happening, examples.
In policy, perhaps?
Sure. So in terms of, let's just forget NAT and keep it fairly straightforward, right? So we have a table 0's port security. So it's based on the import, the MAC address, and we know these things based on the endpoint. Okay, so we know those things about the endpoint. And once it gets through there, We then map it into what source group it belongs to, right? We also know what parts of the forwarding model it belongs to, right? So the layer 2 namespace, layer 3 namespace, we also know what source endpoint group it belongs to, right? Then from there it goes into the destination mapper, so we know things about the actual endpoint destination. So then we can work out things about its namespace. They're going to be in the same layer 3 namespace, they have to be, because that's in the matcher. So I'm talking about the actions now, right? Because you're assuming you can match on the traffic. And then, that's where we set things like the destination endpoint group and its forwarding domain in terms of its flood domain and bridge domain. So we know things now about both endpoints, source and destination, right? Then we can go into the policy table, right? So let's just say we're classifying on port 80, destination port 80. So from there, we know that normally the action would be allow, and that's how you allow traffic for a client to talk to a web server. If the action is chain in the contract, then what we do is we obviously know the name of the chain, right? So we request to SFC some information about that chain. So we request the RSP. If that RSP does not exist, as part of that request, we create it. Now, when that creation event happens, there's a notification in the data store. SFC OFL2 then takes that chain, it takes that RSP and converts it into flows. So the first thing it's going to do is it knows the first NSP, NSI, right, for the NSH header, and writes flows saying, say, I'm going to match on NSP1, NSI 255. And he uses different tables for that, right? And then you send to the service function, right? The service function takes it on 1255, it decrements the NSI, that comes back in. So on ingress, and it's still the same import because it's all VXLAN encapsulated, right? He's now looking for 254. When he sees 254, based on what the RSP says, he takes it to the next SFF, and so on.
Yeah.
Well,
Well, it's more than just
You walk it through
the
the
whole
service
thing.
chain, and then,
Yeah.
right, and then on egress, right? So as we've classified it, and we know that that NSH header, right? Let's just pretend that SFC didn't exist, and we're just doing allow, and so we know the destination over here, the IP address, right? That we would have sent it to because it's an overlay solution. So we take that data, so the destination IP and the VNID, and we put that into the metadata of the NSH header, and that gets carried through the whole chain. Then on egress, when he sees, the last -1, right, NSI, he then instantiates, the right destination IP address, right, the right VNID, and it gets tunneled back to the destination OVS. And then we go through that process again, right? And we look for the NSH header on ingress, so we don't reclassify and you end up in a loop. So, that's the pipeline in a nutshell. Is that the level of detail you're looking for, or?
Kind of wondering, so you're describing all the stuff happening in your base policy, then feeding into the service function, SFF, SFC, and then coming back out. I'm wondering what's happening at the overlay layer in your model.
So my thought is, go ahead,
that's the
go, please.
I don't know what else you want to know.
I'll ask my question. I'll give it back to you. You put the mapping of where you actually wanted the packet to go to at the end, if SFC was not there, in the context header of NSH. So that means that if you had to work with another service, let's say, I don't know, some other service, and they had their own header, then you had to somehow manage to input that kind of information of where destination has to go to into another kind of header, or that's the model you're using, right now.
Are you asking if there wasn't NSH or context metadata?
No, I'm just saying that I'm saying that you're tailoring. The solution is depending of. I want to generalize the solution, right? So now group-based policy has is using SFC in the middle as a part of the policy or part of the action in the policy, right? So and SFC has a header and in NSH, and then you're embedding some information that you need at the end of the chain in that header. So if you were using some other service and there were other different headers there, you would have to, change the behavior to adapt to those headers and store it somewhere there. That's what I'm saying. So it's hard to generalize right now. So we need that's a question.
Agreed. So just looking at this, and sorry I was late. So what I just described was green, orange, blue, orange, green. That's what I just described. So I don't know if you need to, if that's meant to be representative, but in terms of the flow, it's green, orange, blue,
Well,
orange, green.
What I was trying to get at was the definition of the
yeah. So I'm
Overlays, transport, SFC as service, and policies classification.
yeah. So I mean, I was less trying to.
That's
I was actually less trying to with this picture to sort of say these are the one true layer. This is the one true layer stack.
Don't run away. Hey, actually, she brought up a very good point. Is that
Yeah.
I think subtly in her question, if you read, is that can you define the pipeline without knowing what are the other entities that are coming down the pipeline? Meaning, in this scenario,
Yeah. How far? Basically, the question is how much arm's length can we get between, in terms of the rest of the pipeline. And by the way, this is just like my random conversation starter idea of the possible layer stack. But we did have one other question Andre wanted to raise, which is his question really was, you gave a great answer for what's actually happening inside the box. But I think his question was basically sort of like, what is policy? Things like, administrative access, Yeah, so like policy, a good example of policy is do you allow traffic at all between these endpoints?
Sure.
But there can be other sorts of things. Maybe you apply a certain kind of quas or all kinds of other things that is a policy layer at the top level.
Yeah, so, it's just my personal definition, right? It's not like, thou shalt, this is what policy must mean for all of OpenDaylight. We're a project, this is what we do, right?
Yeah.
I'm not going to go tell another project, no, that's what, you're not doing a database, you're doing something else. It's like, whatever, that's what you do, right? So, to me, policy is the conversation that happens between, right? So, very concrete in the simple IP stack. It's the protocol, it's the layer 4 ports, it's the classification things. Things you would typically put into a firewall rule is the simplest way of looking at it. Or what an application API looks like. So an application API doesn't wave its arm and says, I'm .10 on this. That's an endpoint thing, right? So that's, to me, policy is that classifier that's not the concrete IP address, it's more the ports and the protocols that it's using.
Yeah, it's
But to me, and then it's the rules that you do when you see those classifiers, whether it's allow, deny, chain, mirror. There's probably only big 6 ones. But that's just does that help? Like,
It does a little bit. I mean, but you're trying to propose a kind of formal.
kind of a framework where we can sort of work out the minimum necessary common concept where we can actually do some work in a way that we interact well together.
I think it's important we have some sort of consensus and discussion, and I'll give this back to you, Ed. And
Give it to whoever else wants to talk. I'm trying to talk as little as possible.
I think about this a little bit differently. Right? I think about this not in terms of hierarchy of this is this thing, this is this thing. I think about it as the pipelines in terms of namespaces and the interdependency of namespaces, and I'm trying very hard not to think about things as a hierarchy anymore. So I don't know. So that we need to have a broad discussion.
I'm going to turn my mic off for a while the mic makes its way around the room because I think there's a lot of good stuff happening.
So my question is, are these kind of applications right now that we are looking at in this particular picture, policy, SFC, overlay, these, to me, it looks like these are not trampling on each other anyway. At least this particular example.
They don't have. That's the idea is to sort of try and figure out roles where you could not trample on each other.
But my question is not that. My question is, so like it looks to me that these are applications which are not going to trample on the same kinds of flows anyway. No, so what would happen when, I mean, this is more of question to, let's say, Flavio, and what happens in the case where OVSDB and the network virtualization project and the GBP, can they be working on the same switch together ever? Or it's something that is it's absolutely not a possibility. Like you cannot ever say that that
It's almost like the new OpenFlow plugin and the old OpenFlow plugin. You use them together.
yes. So yeah.
They have very similarity on what
Yeah. Yeah.
things they're trying to accomplish.
What,
So,
what I'm,
yeah.
I mean, yeah.
Yeah.
I mean, part of what I'm trying to work out in my head is, at least in my own head, is there is sort of fundamentally incompatible,
Yes.
meaning that we're trying to do things that can't both be done at the same time. And then there's incidentally incompatible, which means, yeah, we're both doing stuff, and because there's no sort of like conventions about how to do it in a way that isn't going to stomp on each other, no conventions about how to hand things off between each other, we're going to collide not because we had to, but just because like no thought was put into not colliding.
Yeah. Okay. Can I can I ask? Yeah, yeah. Before that,
Okay, just sit next to them, okay?
Yeah. Before that, I mean, because we are doing these at two like different tables, that inherently means that some things are going to be hitting the pipeline first and have a higher priority and all those things. So, do we need to introduce some things like the way we used? I mean, we discussed this over IRC channel. The way the routing protocols have this like administrative distance between different protocols, which is a higher priority, which you want to hit first between these applications also.
It's like just for that picture, I don't want to handicap the fact that in OpenFlow plugin you have this thing called resubmit, which allows you to do all sorts of wonderful things. You know, the arrow can actually go both ways.
It goes round and round and round.
Yeah. So I don't want to limit what OpenFlow plugin can offer to the app, by introducing some sort of a.
Well, and the thing is, like, I really am not trying to shove necessarily. I mean, I'm fond of this model. Let's be clear, right? But I'm also aware of the limitations of my own imagination and my propensity to be wrong on occasion. So really, it's most productive to think of this as a conversation starter rather than something that's chiseled in stone.
Yeah, and that's the key thing, right? So coexistence is a problem. Like OVS is the edge switch to Jura. Let's just face it, right? So it's not just a GBP, SFC, network thing. There's going to be other projects, and they're going to want to do stuff with OVS. So we have to deal with this. My personal view on this is I'd prefer to take a namespacing-based approach with recirculation, where you have to enter the pipeline on the same switch because you can't tunnel to yourself, right? Just won't let you do it. I like the idea of administrative distance because you've got two problems, right? First problem is table zero, right? Everyone has to use it, and it comes in as ideally a naked unclassified packet. So you need to sort that out. The next problem then is how do you actually separate the pipelines? And so Ed's got his idea here of taking it more from, I'd say, a topology taxonomy type idea, perhaps. I was looking at this more from a namespacing idea of leveraging metadata. So you tag, each of us would get a namespace, and you'd tag on table zero, assuming we can solve table zero. a namespace, whether it be NetVert, GBP, SFC, and then from there on you match, right, on your namespace. There's also a pattern we'd have to adopt in terms of how we interact with inventory conf in writing flows. You know, if you add, delete flows, you can only do it for your namespace. And Tony Tkachik is here. So Tony had some good ideas around OpenFlow plugin offering more like auth-C, auth-N type stuff. Yeah, that. Or ownership, Flavio said. There's another proposal around kind of not allowing people to write to table zero. So we'd all think we're writing to table zero, but we're not, and doing conflict resolution in the OpenFlow plugin. And really wish Tony was here because he had some really nice ideas. He also had some ideas around how this, some translation functions. So we all think we're writing to 255 tables, right? But we're not, you know, because some hardware switches don't support that. Some hardware switches don't support every single type of matching capability in every table. So he had some ideas, and it's a real pity he's not here. So, you know, I think we all have slightly different ideas on how to approach it, but the key thing is we have to address this. Anyone who says that we don't, I think,
I don't think the ideas are necessarily incompatible. I think, like, if I understand correctly what you're saying about using metadata for namespaces, what you're basically saying is that somewhere we have, and this is the table zero problem, we have some way of saying, okay, this guy goes first. Now that's somewhat of a big if, but if you have some way of doing that, you can mark that packet, you can set metadata for that packet, and then everything else in that guy's pipeline is matching the metadata in addition to whatever else he's looking for. And at that point, you don't have to figure out, you can blend the tables together because who cares? You effectively have this overlay effect with tables, which is kind of spiffy cool. But you do still have to figure out, if you're going to hand off to somebody else, what the hell table you're going to, and what his metadata is, so you can basically indicate that it's supposed to be his. Yeah. Yeah, you have to change the namespace. So if you're going to SSC, you got to know what the first table of the SSC pipeline is, and you've got to know, or maybe you just recirculate. Maybe you just do a resubmit, and you've got to reset the metadata to match SSC so that it comes back around.
So I worked on one thing which I think I'm almost mildly proud of in the Open Networking Foundation, and the Open Networking Foundation hasn't done a ton of things that I'm proud of, but some of them, which is called table type patterns. And one of the things that I learned in table type patterns that is really critical to understand here, and I think Tony's on entirely the right path, is this idea that you want to separate the logical pipeline, which you actually program, from the physical pipeline that exists in the switch, and that is absolutely critical to getting this right. And that's what you start talking about. Like, you might think you have 255 tables, but you don't. And it's virtual memory for flow tables. That's what it is. And that way you basically construct a virtual pipeline of what your app is supposed to do in the controller, and you translate that into what the hardware is capable of, or in this case, what the Open vSwitch is capable of. And at that point, you don't have to talk about metadata, you don't have to talk about anything else. Like, you can use metadata for it if you want to. You could also compile it down to just sections of tables, right? You could just say, by definition, if you're in table 10 to 17, you're SFC, right? And so when I want to deliver it to SFC, I deliver it to table 10. That's the beginning of SFC, and I go through it. The point is not that that's better or worse. It's just if you separate the actual construction of the tables in the switch from the logical pipeline at the top, you will be much happier with life.
So you are selling virtual tables?
Yeah, virtual memory for flow tables. That's my pitch. Virtual memory for flow tables. No. It's a virtual pipeline in the controller. I mean, it's not another virtual switch. It is a virtual pipeline in the controller. And a pipeline is different from a switch, right? It is a particular set of ordering of operations, which then gets compiled down into an implementation in a switch. And the point is just, I think it would help us if we moved up a layer, not talking about actual flow tables and an actual switch, and say, here is logically what I want to happen as a chunk of functionality, which I think is exactly what Ed is talking about in terms of his chunks that we can see together. And that basically, but you have to intentionally leave underspecified or understandably translated details about the particular flow tables because they're going to be rewritten, and we have to either build the translation back and forth or something else. Anyway, basically I was just trying to say this is the right approach, at least in my opinion, and a lot of work has been done thinking about this in a lot of other places where we can go steal it and just run, which would be also really useful.
Yeah, one other thing really quickly, I think before you got here, there was a question about TTPs and how that might play into this. And the question was, have you given any thought to that? And my response was, in precisely the sense that you asked, I have not given any thought to it, which means I don't know enough to have any intelligible thoughts. So I don't know if you have any intelligible thoughts you could contribute.
In the sense that TTPs are a way to define a logical pipeline. Right? That's it. I mean, all a TTP is a somebody's spec for how it is that you define an open flow pipeline. It says this chunk of functionality has the following tables. They have the following numbers. Each table can do the following matches, the following actions, and you can jump between them in the following ways. And so in that sense, it is just a description of one pipeline. And if you think about it as a pipeline snippet, then you can chain them together into a larger pipeline.
See, now I feel really silly for not having known more, because it sounds like you're describing very precisely what I think at least is needed, which is like, this is the set of things for this role, this is the set of things for that role, and this is how you move between them, which is really what I'm sort of advocating for.
So, yeah.
There's other ways of handling that, right? So that you're still constructing the packet headers, right? And there's other ways of kind of tracking that. We could leverage serial registers for argument's sake, right? And just basically say like this is a reference to this thing, right? This isn't gonna be some magical pill where we can all go off and do it any way we want. We have to agree on a pattern that we're all going to work with if this is going to work. If we want to do it this way, right? In terms of not having OFP say this is a solution for it, whether it's translation, TTP, what have you. Yeah. I'm just thinking about ways that we could go and code on it. I could go and code on it today.
Yeah,
right? Without having to go rewrite OFP.
Yeah, and just to be clear, like I don't think anybody's advocating this is the one true way and you have to do it this way. It's like if there are a set of pipeline snippets that can collaborate together this way, that works.
I have a question. So, can you put the slides on, please? So the way you have this set up is it implying that the only packets that will get into SFC come from policy? Because that's not necessarily the case.
I can absolutely see how it looks that way. I did not mean to imply that.
Yeah.
Consider it a limitation of my artistic skill.
All right.
And in fact, like the order in which things come in, one of the things I thought along the way was sort of like having separate ingress and egress pipelines where you come from the bottom of the stack up on ingress and the top of the stack out on egress, in which case you might imagine a situation, and I haven't thought it all the way through, where like you actually hit SFC after you come off overlay, you hit SFC first on the ingress, and then if it's just a purely SFC thing, it loops around through the service function and back out to the next point in the chain. It never necessarily hits policy at all. But if SFC is coming in and it goes out of SFC and up to policy on ingress, then on the way out, you traverse the other direction.
Yeah.
Kind of a random thought, not sure if it's a good idea or not, but that was kind of one of the thoughts that was going through my head.
Like packets for SFC, they can come from either, in this case, either GBP or from a service function. And the packets from a service function don't go through policy. So how?
Oh, absolutely. That was kind of the point of what I was saying about if
So
you
then
separate the ingress and the egress and you go the opposite direction on each one, that might give you something there, because then SFC essentially, it comes in first and SFC says, okay, is this one of mine?
Yeah.
And if it's one of mine, then you send it to the SFF, it comes back as one of yours, and it goes out as one of yours.
Yeah, that's the question. How do you say, how would either policy or SFC say, these packets are for me? I guess you would somehow have to register, or how? But does that still in this?
You could do it one of
still have the table 0.
You could do it one of two ways. You can do it one of two ways, right? And I don't know what the right answer is yet, right? One way, which was kind of the one I'd thought a lot more about personally, was to say you actually have a stack. So you come in you come in traversing up the stack on ingress and out the stack on egress.
Yeah.
So you come in, you come off overlay, the first thing you hit is SSC. SSC checks to see if it's an SSC thing supposed to go to an SFF locally. If so, it does its thing. Then on ingress, if you aren't an SFC thing or you're being uncapped as an SSC thing and you're on your way out, then you go out up to policy, then across egress policy, egress SSC, et cetera. And this isn't really, it's not actually sidestepping the table zero problem. It's just sort of like being really sclerotic about the table zero problem and saying, we're going to decide on a particular order of pipelines in the stack. I think there's a lot of value in having more flexibility, but then you got to figure out how do you going to put the first metadata header on from Keith's point of view, or basically how are you going to determine in table zero the first pipeline that you're going to go to in the stack. And one way is just to say it's always this way, and the other way is to try and find out something smarter.
So, I mean, we have 20 minutes left. I mean, this is good stuff. How are we going to get into, or did I step over somebody? Sorry.
Yeah, we got more people back here.
Let me start over. Just one quick point about this, about the namespace approach that Keith has been mentioning and Colin was also talking about. This does not necessarily have to be mapping to a single, different tables. It can be a partition within a single flow table also. So I mean that way we are not really constrained to using this kind of an approach only with an OVS.
I think that was part of what Keith was suggesting with metadata, maybe. Was that you could almost have use almost like virtual tables, except we're engineers, we get stuck in the details.
Yeah.
Yeah.
This works really well in virtual switches. Making this work in hardware is going to be painful. And I just
already acknowledged. Yes, totally.
And so yeah, I think that's all. And I think Abhijit was basically saying if you are willing to relax some things, you might and do sort of the translation which Tony and Keith were talking about, and I sort of mentioned. You might have some hope of getting it to run in real hardware. Real hardware doesn't support metadata. I mean, it does, but not in OpenFlow in practice. I don't know of no hardware OpenFlow switch that supports metadata, or most of the things that were mentioned here. So the question is, how do you make this work with multicast or not point-to-point communication?
That's okay.
Mike? Or actually, give him the mic. He needs the mic. Okay.
No, I would just say that this kind of a layering model is the only way I can imagine unicast and multicast being supported, because that the forwarding mechanisms are so vastly different. And if you try to make your forwarding policy a union of that, it would be a disaster. But I mean, that's just the way I look at it.
Okay. We're oddly silent. Surely someone wants the mic. You'll take it back?
Well, the classic example of this is always to treat unicast as a special case of multicast.
Yeah, I mean, my thought had been multicast. Well, I mean, you know me. I'm a little more cavalier than that. I'll say we don't know, but I have wild-ass ideas. So the notion being that basically when you get to the overlay pipeline, which is when you're really dealing with sticking this stuff out on an interface for the null overlay or out into a tunnel, multicast mostly comes down to figuring out what you're doing for replication, meaning multiple outputs. And so you might have policies about multicast, or you might have, do we do anything with service function chains with multicast? Oh, thank God. So you might have policies about multicast traffic, but I wouldn't expect it. The thing that makes multicast tricky is that you've got this replication problem, and that would be something I think would fall down to the overlay layer to figure out how to have multiple points of output. Yeah, that could work.
Okay, I'm going to toss in my. Okay, so it isn't just about replication, right?
Excellent.
I mean, if I send in, a multicast packet into a routing infrastructure and I just replicate it without having trees that direct it to the people who have joined, I just
True.
flooded my entire data center with replicated packets, right?
True.
What does OpenFlow give you? OpenFlow gives you the ability to flood, right? Which is what VMware does with their virtual, their switches right now. They don't do multicast, right? What they do is they get in a packet and they guarantee that it won't go back up where it came from and it goes out everywhere else. So every time you get in a Class D packet, off it goes, right? So you just flooded your entire data center with a packet that was only intended to probably go to one receiver. Right, so it isn't, all I'm saying is that policy isn't about replication, right? Policy is about the creation of trees that guarantee you that you're only routing to the people who have joined, right? That's a bigger problem than just saying I'm going to replicate somewhere. I mean, I can do that with PIMs right now.
So to a certain extent, though, I think you're getting into the question of how you know where you should replicate.
That's right.
Right.
Yes. And to me,
that's a complicated problem. I agree.
yes, it is. And the problem is that you also have to do it in advance.
No, I completely agree.
You have to choose your rendezvous points. You have to, I mean, you got to turn on, you got to enable multicast for everybody, right?
Yep, I completely agree.
You have to choose your locations in advance.
Effectively, though, I was being a little overly cavalier which is to say, yes, you have to figure out where you want to replicate, but once you've actually figured that out, which is non-trivial, at the point of the data path where you presume you know where you want to replicate, it becomes a problem of replicating it.
Yes, but it isn't just that. It's replicating it and then sending it only down the ports that are relevant to that particular Class D address, right? So you replicate, but then do you flood?
Yeah, no. I mean, and
that's not a good answer.
No, I agree. And there's a whole set of problems around multicast, but it's a little bit off from trying to figure out the stack piece, because I don't think the problem gets particularly harder by having it in an overlay layer or some other layer that handles multicast, right?
All right. Granted.
I just have a quick question. So is our discussion limited to only OpenFlow switches or certain technology?
It's actually
'Cause I
not.
think we should cover not just the OpenWith switch, right? Also,
you actually get to a really, really good point, which is, and this is like, again, half-formed thoughts. The whole point was to get this out here where we could actually talk this out. Right. So in my mind, half-formed thoughts, which may or may not have any correspondence to reality, was that like you have up at the level of sort of like the applications, policy, SFC, et cetera, there's this chaining, and then there's also the collaboration that happens at the level of the renderers that are talking to the same box, right? And so we kind of have been focused, because it's a problem that's really, really hard, on how you deal with where you get to the level of the renderers where you're talking to the same box. But you're absolutely right, there's also sort of this question of how you do this up the application layer, and I'll be completely honest, I've thought about it just far enough to sort of think that it looks easier, so I'm going to think about the harder problem first. Might be wrong.
But just to add to that gentleman's comments, so talking about unicast and multicast, guys, I think service functioning is not the only abstraction, and you can cover all the cases. For the multicast, like you need some kind of a layer 2 or layer 3 kind of primitive also there, like some kind of abstraction. So for example, maybe we need some layer 2 logical switch or layer 3 logical router, kind of a primitive in that
Could you help me understand more why? Because I've often tended to think about it in terms of saying, okay, if I'm thinking at L3, I'm in an L3 context, what I really care about is getting from place to place and then whatever administrative rules I apply that, and likewise within an L2 construct. But you may have a different way of looking at it, so I'd be curious.
Yeah, layer 2 give you like a a broadcast kind of a traffic paradigm, not like because we only talk about pipeline. I mean, pipeline sounds like only for unicast, right? You don't support a multicast kind of communication paradigm. Because in my opinion, I think service functioning is not the primitive can cover all the cases. We need to extend that primitive to be able to cover more broader, communication.
Why would you want a broadcast domain if you
for
didn't
example,
have to have
how
one?
do you use the service functioning to describe a layer 2 connection, like a broad flat domain, like a multicast?
I don't think of multicast as a flood domain per se. I just think of it as a replication problem from someone who's sending. It's a point to multi-point problem in my mind, not a broadcast problem. Yeah, I think we're not. Yeah.
Yeah, so
Yeah, no, I think part of it is if you happen to be thinking in terms of L2, you hit the overlay layer and you're being put on an L2 overlay versus you hit that L overlay and you're doing something that's L3, you hit an L3 overlay. So it kind of comes down to some of that rather than sort of broadcasting and trying to do broadcasts over tunnels are really mean and nasty and ugly.
But even the logical pipeline, I think, is not proper word to describe the traffic because it's not really a pipeline. It's like it's more like a graph. How do you cover the kind of the communication, multicast, those kind of paradigm is not like pipeline. I think it's hard using logical pipeline to describe all the traffic.
So
pattern.
I apologize. We've hit the end of the session. The next session in this. Yeah, the next session. I'm sorry, what? I know. I mean, this was mostly, like I said, about starting the conversation. Could we get someone to take this conversation to discuss so that we can get it kicked off and moving forward so we can continue the conversation on email? I'm kind of agnostic. I tend to think of it as bigger than OpenFlow plugin dev, but I'm totally willing to go that way if that's where people want to go. All I care about is that we get the conversation continuing, so I'm good with that. Yeah, it'd be nice to let Discuss know, because I don't know that everyone who's necessarily interested is monitoring OpenFlow plugin dev. Okay, cool. And then the other thing is we're actually, I think next session in this room after the break is actually trying to dive in and look at, okay, what would we want at an overlay layer for this? Because my impression has been, and the folks who are actually doing it can tell me if I'm full of shit, that particularly when you get to multiple people living together, that having everybody managing their own overlay layer is a bit of a pain. And it might be nice if we can find a reasonable way to have a common overlay layer that can be used by various other applications so that you don't have to take care of that part of the world for you. Just like the example of like nobody wants to do their own ARP neighbor discovery if they can find a better way to have that handled for them. Which is a simpler example. So that's what's going to be, I think, in this room next after the break. So, but thank you guys for coming, and I really appreciate like how lively the conversation was, because I was really dreading the notion of having to actually stand on stage and talk and talk and talk and talk. Thank you.